High intensity discharge lamps. High intensity discharge lamps have lifespans and efficiencies similar to those of fluorescent lamps. Unlike fluorescent lamps, the gases in the high intensity discharge lamps, much shorter arc tube, operate at a much higher pressure, with more of the light output being in the visible portion of the spectrum. Like fluorescent lamps, they require a ballast to initiate an arc and control the current. A separate igniter is used in some designs. Here's a highlight. Mercury vapor lamps are the oldest of the high-intensity discharge lamp types. Mercury vapor. Their blue-green light output has a relatively low color rendering index and a modest efficacy of 50 to 60 lumens per watt. They're rapidly disappearing from use because other types of lamps and luminaires have a much better color rendering index, improved efficacy, and a longer life. So, low pressure sodium, because they operate at lower pressure than other high intensity discharge lamps. Low pressure sodium lamps are very closely related to fluorescent lamps, with a length that varies according to their wattage. They produce a monochromatic yellow light due to their coloring rendering index of 0. All objects appear yellow or black, but have a very high efficacy, 200 lumens per watt. Due to decreasing use, major manufacturers of low pressure sodium lamps have announced an end to the production. High pressure sodium. By using a much higher pressure in the arc tube, high pressure sodium lamps produce a golden white light compared to the pure yellow of the lower pressure sodium lamps. High pressure sodium lamps have a better color rendering index and a higher lumen output than the mercury vapor. They also have a longest lifespan of any high intensity discharge lamp. High pressure sodium have the longest lifespan of any high intensity discharge lamp. High pressure sodium lamps typically blink off and restrike at intervals of a few seconds to a minute or more when failing because of the loss of sodium in the arc tube. All right. Metal halide, they're very similar to mercury vapor. Of all the high intensity discharge lamp types, metal halide lamps, also called multi-vapor lamps, have the highest color rendering index. Metal halide and high pressure sodium are the two most common types of high intensity discharge lamps. Arc tubes rupture can be dangerous. NEC section 410-130 F5 requires all metal halide lamps to either have a containment barrier, such as a lens, or be type O with a protected socket. The only exception to the requirement is thick glass parabolic aluminized reflector, and type O lamps have an internal shroud that protects the outer bulb from damage if the arc tube is ruptured. So here's your metal halide. Here's your high pressure sodium. I shouldn't tell you this, but the inner glass tube of this high pressure sodium are very good for sharpening your pocket knife, especially if you have an edge already on it and you just need to touch it up. You need to just clean up the edge. I don't know what kind of dust they have on the outside of them. There's some kind of a dusting on the outside of this glass tube. So when you break this tube and you get this glass tube out of the center of it, if the high pressure sodium has gone bad, it's no longer working, you break it and you get that cylinder out of there. And it's small, it fits in your toolbox, and you can use it, like I say, just to put an edge back on your knife. If you were just cutting wire or cardboard with it and you've dulled it just a little bit, just a couple of swipes along that, just like a sharpening steel. You just use that, you hold it in your left hand if you're right-handed, and you just run your blade over it a couple of times, and it really puts a nice edge on your knife. Going green, efficacy. All right. The advantages of high-intensity discharge lamps include compact fixture size, greater illumination than fluorescent incandescent lamps. The disadvantages are special disposal requirements, danger of lamp explosion, ultraviolet light damage to paints, plastics, and other items, delay of 3 to 7 minutes for switching on until the light output reaches full brightness, color down period required before restart when turned off for any reason. You remember the Super Bowl where all the lights went out and everybody was screaming for the electricians to get the lights back on? Right restrike. There was nothing they could do. Something happened, the lights went out, they reset the circuit breaker, everything was a go, but those high intensity discharge lamps had to cool down, and it took 5 to 10 minutes for them to get to a point where they were cool enough that they could restrike, and then take another 3 or 4 minutes to come back up to full brightness. So it's the type of lamps that they're using. Now I'm sure that they're going to all LED, which you can start in milliseconds. If you find that there's a breaker out and you reset the breaker, the lights will just come right back on. You won't get that 15-minute delay with everybody screaming. Magnetic induction lamps. Induction lamps are essentially a type of fluorescent lamp without any electrodes. They function like a transformer with an external primary winding in a toroidal shape and a circular discharge tube filled with low pressure gas that acts as a secondary winding. The absence of electrodes results in a lifespan of up to 100,000 hours. Man. When used with electronic controls, they can operate at high frequencies that prevent flicker. Some types use radio frequency induction to power the lamp, but it's important to select frequencies that do not interfere with communications. Variation on induction lamps uses higher frequencies to energize the tube components or contents into plasma. At their design operation temperature, the lamp has a very high color rendering index. These types of lamps use magnetron and waveguide to put the energy into the lamp, reducing their lifespan. To me, magnetron and waveguide sound like somebody's got a copyright on those terms. All right. Advantages of magnetic induction lamps: long life, instant start, no flickering, low temperature operation. Some are dimmable, high power factors. The disadvantages are special disposal requirements due to mercury content and limited use. We have the xenon arc lamps. Early arc lamp types included carbon arc and lime lights. Modern arc lamps use a very high pressure xenon arc to produce pure white light, color rendering index of 95 plus, with a color temperature of 6,000 kelvins. The arc is in a very small area surrounding the lamp's cathode. This allows the light output to be focused onto a very controlled beam with uses ranging from flashlights to scientific instruments, lighthouses, searchlights, and theater projectors. So here's your xenon arc lamp. I want to say that there are some photography uses for them, for flash photography, because they create a very bright light with a good color rendering index. Advantages of xenon arc lamps: use of the significant UV light output for ozone generation, disinfection, medical research, no loss of light output over the lifespan of the lamp. Lifespans rivaling those of LED lamps, and they're dimmable. Disadvantages are danger of lamp explosion because of the very high pressure, so special handling is required. Ultraviolet light damages to paints, plastics, and other items if UV filtering is not used. Two point 2.0 Components of luminaires. 2.2.1 Lamp shapes and dimensions. Lamps are made in numerous sizes and shapes with different mounting bases. Here's a highlight. It says, lamps are identified by a letter referring to their shape and a number that indicates the maximum diameter stated in eighths of an inch. For example, in the United States, an A40 identifies a lamp with an A shape that's 40/8 of an inch in diameter, or 5 inches in diameter, while a lamp designated a T12, and that's that fluorescent lamp, is 12/8 or 1.5 inches in diameter. So here are the different shapes. Here's an A. A is your regular incandescent lamp. A T is cylindrical. So fluorescent lamps fall into that T shape. Even though they don't have an Edison base, they have pins. We have floodlights. Floodlights are parabolic, PAR. So here are different types of parabolic reflectors. Lamps with standard tubular and similar envelope shapes provide lighting in all directions Those with shapes designated as R, ER, and PAR are all reflector type lamps. They direct their light out in front by reflecting it from their inside walls. So you've got a filament in here, and all of the light flowing backwards from it would be wasted. Only the light coming from the front of that filament would be visible. So they have this reflector, and it's parabolic, and it focuses the light. No matter where the light hits it, it reflects outward. And then they have different beam widths. You can have spots or floods, and that's the spread of the light. I forget. I think a spot is 30% or less of spread, and anything greater than 45 degrees or greater, I think, is a flood. Fluorescent lamps are designated by the letter F, followed by the wattage, the letter T for their tubular shape, diameter an eighth of an inch, the color, and any other characteristics. If the fluorescent lamp is bent in a U or a circle, the letter F is followed by a U or a C. Compact fluorescent lamps do not have a standard labeling convention. High-intensity discharge lamps come in some of the same shapes as incandescent lamps, plus BT, blown tubular, and ED, elliptical, dimpled. Lamp holders. Lamp holders allow the lamp to be installed into a luminaire in the correct position and orientation. They must match the lamp type and size, including wattage, voltage, and pulse voltage for high-intensity discharge lamps. They must also be suitable for the temperature, environment, luminaire material, wiring method, number of lamps, switch control, and other factors. Lamp holders generally fail because of heat, breakage, or corrosion. The cause for lamp holder failure must be identified before any replacement is made. So, lamp holders are generally identified by a letter identifying the type and a diameter or spacing size in millimeters. Thus, a screw shell lamp holder, what we call an Edison base, may range from an E10 for a flashlight to an E27, which is the standard medium base. And then they have Mogul, which is even larger than standard base. The range continues up to an E40 or, oh, there it is, Mogul. There you go. Other lamp holder designations include BA for bayonet type, G, GU, GY, GX for single pin or bi-pin types, W for wedge types. Some E-type lamp holders have an extra contact point for use with three-way lamps. Certain G types have one or two contacts for use with tubular fluorescent and replacement LEDs. So here are the ends of a fluorescent fixture. This is what we were talking about before. I think we've mentioned the shape of the tombstone. This is a tombstone. It's a bi-pin slide-on lamp holder. When you go to the supply house and you ask for it, you ask for a tombstone. And you designate either a T8, T12, or a T5. T5s have a smaller pin orientation. They cannot fit in the same tombstone as a T8 or a T12. And these are single pin. These are the high output. And they have a single pin. You push them in, or they're the what was it? Instant start. They said instantaneous start lamps have a single pin in them. One side has a spring so that this can actually be depressed. It can be pushed in. That's how you get them in. You push this side in, the other side is stationary. You get the pin lined up over there, and then as you let go, this is going to spring out, and then it'll hold the lamp in place. And installing lamps, make sure the lamp and luminaire are compatible. High-intensity discharge lamps make sure that the orientation in the lamp of the luminaire, such as the base up, matches the burning position marked on the lamp. Also make sure that the American National Standards Institute code on the lamp matches the ANSI code on the ballast. Make sure the lamp has the correct voltage rating for the luminaire. This is especially important when installing incandescent lamps because the small difference between the rating and the actual voltage negatively affects the lamp's life and light output. Make sure that the maximum luminaire wattage rating is not exceeded by the replacement lamp or combination of lamps. That's what we were talking about before. If you have a recessed fixture and it says maximum 60 watt, and the customer puts a 100 watt light in there, they're going to affect that thermal uh, safety, thermal switch. When installing fluorescent and high-intensity discharge lamps, make sure the lamp type and wattage are matched to the luminaire and the ballast being used. When installing bipin fluorescent lamps, make sure to rotate them quarter turn to seat and connect them. Do not install lamps that have scratches or otherwise damaged envelopes. Use a soft cloth or gloves to handle an unencapsulated halogen tubular lamp. This prevents oil on your hands from contacting the bulb. The quartz tube walls can withstand high operating temperatures, but will overheat and crack if contaminated with fingerprints and other materials. Also, make sure that no combustible materials can make contact with the lamp when illuminated. Unlike standard lamps, halogen and high-intensity discharge lamps may continue to light even if the exterior lamp glass is broken. Replace the lamp immediately regardless of whether it still lights or not. In some applications, such as food processing plants, bakeries, dairies, schools, and warehouses, safety sleeves should be used to cover the fluorescent lamps. This helps contain broken glass and phosphors if the lamp ever breaks, falls, or bursts. Always work safely. In general, energy legislation promotion replacing standard incandescent lamps with LED and compact fluorescent lamps, incandescent reflector lamps with halogen PARs, and full wattage lamps with higher efficiency fluorescent lamps such as T5s. If it's necessary to relamp existing luminaires designed for use with a discontinued or an inefficient type lamp, replace the lamp with an approved energy efficient substitute. Make sure that any dimmer used is compatible with a replacement lamp. You can retrofit that lamp, or you could just talk the customer into just putting a new lighting fixture. Lighting fixtures are something you can replace every 10 years. They might last for 20, but I mean, tastes change from time to time. It's nice to give your house a little sprucing up just by changing some of the older looking luminaires with some newer ones. Fluorescent lamps may be used in circuits with an open circuit voltage exceeding 300 volts, or circuits that permit a lamp to ionize and conduct current with only one end of the holder. NEC section 410.71 requires some automatic means for de-energizing the circuit when a lamp is removed. This is usually accomplished by a lamp holder which opens the ballast primary circuit when the lamp is removed. 2.2.4 Fluorescent luminaire ballasts. In fluorescent luminaires, the ballast performs the following functions. It provides the proper voltage to establish an arc between two electrodes, regulates the electric current flowing through the lamp to stabilize the light output. It supplies the correct voltage required for proper lamp operation and compensate for the voltage variations in the incoming power. Provides continuous voltage to maintain heat in the lamp electrodes while the lamp operates. Rapid start circuits. Each fluorescent lamp must be operated by a ballast that's specifically designed to provide the proper starting and operating voltage. Lamp and luminaire manufacturers make a wide variety of ballasts designed for use in luminaires that support multiple lamp starting modes. Ballasts are made for single lamp, 2 lamp, 3 lamp, and 4 lamp operation. If you ever have to replace a ballast because the ballast has gone bad, also replace the lamps. Don't put old lamps into a new fixture or a new ballast. If you're replacing the ballast, replace the lamps as well. Magnetic ballast components lose 5 to 20% of the luminaire's input energy, so they're installed and potted into metal case to dissipate the heat. Magnetic components vibrate at a line frequency, producing an audible hum that can be disturbing in quiet environments. They're generally available to operate only 1 or 2 rapid start or instant start lamps. Since 1988, they've been required to be made with high efficiency components because the increasing availability, wider applicability, and energy saving of electronic ballasts, metallic ballasts are being phased out. Yeah, the new ballasts are all electronic. They don't have that problem with the humming. Here's a highlight. It says electronic ballasts operate the lamp at 20 kilohertz to 50 kilohertz, improving the ballast and lamp efficacy and eliminating audible hum and lamp flicker. Very good. Going green. The names used to identify the different types of ballasts can vary by manufacturer, but are generally of the following types. Rapid start ballast. These ballasts apply operating voltage to the lamp while simultaneously heating the cathodes. The lamp ignites quickly, but if the cathode is not fully warmed, some materials sputter off. So if you're replacing a ballast and it's a rapid start ballast, replace it with a rapid start ballast. Make sure that you're putting lamps in that are rapid start. Same with instant start. These ballasts operate using a higher starting voltage to provide immediate illumination. They offer the lowest system wattage and highest system efficacy and at the cost of shorter lamp life. So again, if you're installing a ballast that's an instant start ballast, the lamps have to be instant start also. Electronic programmed start ballast. These ballasts offer the longest lamp life due to minimal cathode damage when starting and are nearly as energy efficient as instant start ballasts due to reduced cathode heating. Electronic ballasts are often the best choice, particularly for luminaires that turn off and on frequently, such as with occupancy sensors. They're not available in magnetic versions. Emergency lighting ballasts. Special emergency ballasts with self-contained cordless power packs are made for use in some fluorescent luminaires. If input power to the luminaire is lost, these ballasts will typically operate a 1 8-foot lamp at emergency lighting levels for about 90 minutes, or 1 4-foot lamp for about 120 minutes. Basically, they have a battery. It may not be a battery, may be a capacitor, but or an electronic battery, but they've got a storage of power is what it is. So when the power is lost, that light will remain lit. That's why it's an emergency light. It'll give you enough light to exit the building, but it's not going to last for long. It's not going to last forever. So make sure you get out of the building. All right. Case history. I'm going to read that. NEC section 410.130E1 requires all outdoor fluorescent luminaire ballasts, including any replacement ballasts, to have a thermal protective device within the ballast. It's a Class P. So a thermal protective device, it's a Class P ballast. There you go. Class P ballast. P for protection. Exceptions include simple reactance ballasts used for fluorescent luminaires with straight tubular lamps, exit sign luminaire ballasts, and emergency egress lighting. Class P ballasts with thermal protection prevent fires by automatically opening the circuit if the temperature exceeds a set limit due to a fault in the luminaire. Okay. When replacing ballasts, be sure to use an exact equivalent. In most circumstances, if luminaires does not have a disconnect device, one must be installed as required by NEC section 410.71. All right. High-intensity discharge luminaire ballasts. High-intensity discharge lamps require the use of a ballast to provide enough voltage to strike an arc in the lamp. This function may be accomplished by the ballast itself or in conjunction with a separate electronic igniter circuit. An igniter is an electronic device used in the circuitry for high-pressure sodium and some metal halide lamps. It provides a high voltage averaging 3,000 to 4,000 volts to initiate the arc across a gap. When the luminaire is energized, the igniter maintains the arc until the lamp is completely lit and then automatically switches off. So here's your igniter. All right. The high-intensity lamp ballast also acts to control the arc wattage during warm-up and normal operation. In addition, some ballasts provide a line-to-voltage matching transformer function, enhance lamp wattage regulation with respect to changes in line voltage and or lamp voltage, sometimes provide dimming or other control functions. HID, high-intensity discharge ballasts, can be grouped into 3 basic categories according to how they perform. Linear non-regulating circuit ballasts. These ballasts are the simplest and most basic type with no compensation for line voltage dips or brownouts. Constant wattage auto transformer ballasts. Use magnetic saturation in these ballasts to provide good dip tolerance. It maintains better lamp wattage regulation. This avoids light loss due to low voltage arc extinguishment and the 10 to 15 minute required lamp cool down, restrike, and warm back up. Constant wattage transformer ballasts come in different versions designed for metal halide or mercury vapor lamps. Okay, ballast wiring. Manufacturers color code ballast wiring for ease of installation. Always follow the manufacturer's color code when wiring ballasts. When installing new fixtures, the ballast and lamp wiring are typically done at the factory. The installer only needs to connect the line voltage to the conductors matching the input voltage of the ballast. When you're replacing a ballast, it's essential to acquire the right ballast and pay close attention to the wiring diagram of both the luminaire and the new ballast. Okay. 2.2.6 LED drivers. LED drivers provide a stable source of power with a controlled DC voltage and or DC current. That's a highlight. LED lamps are that replace incandescent lamps have the driver in the base of the lamp, which is replaced as a unit. In some cases, LED lamps require a special base that locks it into the luminaire, while the driver itself is in the luminaire. For fluorescent replacement lamps, the LED drivers and lamps save energy and are available in the following variations. Integral driver design for 120 volt operation, requires ballast removal and luminaire rewiring. Integral driver design to operate from the existing ballast and wiring, the simplest but use more energy because the ballast is still being used. A hybrid type integral driver, most versatile and designed for operation while the ballast is operating. It can also be used for 120 volt operation without a ballast. Separate driver mounted in the luminaire in place of the ballast. It requires luminaire rewiring. So for new and retrofit work, an LED luminaire may have the driver within the luminaire, but frequently the driver is in a separate component mounted on or nearby a junction box with a special wiring whip to the luminaire. Different dimming methods, as well as changing the color of the programmed or programmable RGB LEDs are all possible when the appropriate driver and the compatible LEDs are selected. LED drivers use solid-state electronic components, which can be damaged by excessive heat. They're usually identified with a typical operating life of about 50,000 hours at some maximum operating temperature. Maximum temperature is often designated on the driver case as TC. So, temperature coefficient. If the operating temperature is higher than the rated maximum, each increase of 18 degrees Fahrenheit or 10 degrees Celsius will cut the driver's lifespan in half. If used outdoors, direct exposure to sunlight can cause the temperature to far exceed the limit. When this happens, failure is certain. LED drivers can and often do impose harmonic distortions in the incoming power line, leading to higher temperature in the supply transformers and conductors. LED drivers can be designed with a higher power factor and harmonic filtering to eliminate these effects. LED drivers can also be damaged by spikes, voltage surges, and other types of power line noise. Again, they can be designed with surge suppression or installed on feeders with surge suppression. When possible, replacement drivers should be obtained from the luminaire manufacturer. Some vendors of LED drivers have versions that can be programmed for maximum current. However, if too much current is provided to the LED, known as overdriving, it'll shorten the life. Section 2 review. The lamp with the shortest life expectancy is, I'm going to tell you the incandescent lamp. A ballast is used to regulate the current in a fluorescent lamp. Okay. 3.0.0 luminaires. Describe the selection of and installation of luminaires for various applications. Identify luminaires and their applications. explain how to store and handle lamps, luminaires, and explain how to install luminaires. Remember, those are lights. 3.1.0, luminaire and their applications. Mounting operations include the following: either surface mounted, recessed, suspended, track mounted, or pole mounted. Surface mounted luminaires. They're directly mounted on ceilings or walls. They can be incandescent, fluorescent LED, or high intensity discharge. Some examples of surface mounted indoor ceiling and wall luminaires are shown in figure 19. So these are all surface mounted. There's usually a junction box up in the ceiling, and you mount the light right to the box, or there might be a bracket that's suspended from the ceiling, and then the boxes for the wiring. All wiring has to be done in a box, so you have to have a junction box above these surface mounted luminaires. This one's surface mounted on a wall. Again, there's a box behind this luminaire in the wall. All splices and taps have to be done in a box. There's an outdoor surface mounted. Recessed. As the name implies, recessed luminaires are mounted into a surface, most often a ceiling, so that the main body of the luminaire is not visible. Figure 22 shows examples of recessed luminaires. So this is all you would see. This would be flat or flush with the ceiling, and the light would come out of it. Here's the ceiling, and this light is up in the attic. There's the junction box. Same with this one. It's up in the attic. These are recessed. Other recessed luminaires called troffers are square or rectangular units installed above the ceiling. They're typically 2x2 or 2x4. We use those in drop ceilings a lot. So they'll take out enough ceiling tiles to give you a 2x4 opening, and then this lays in. And yeah, the fixture needs to be supported on by at least two opposite corners from ceiling wire. You can't just suspend it from the grid. The only exception to that is if the grid itself is suspended at two opposite corners, and then you attach the luminaire to it using either screws, brackets, or some kind of hurricane clips that prevent the light from falling out of the ceiling. Some troffers have a mounting flange or a separate kit with brackets that allows them to be installed in ceilings recesses beneath the plastered drywall or concealed frame ceiling system. LED luminaires make excellent choices for troffers because their reduced thickness, as little as 5/8 of an inch to 16 millimeter, means they need little clearance above the ceiling. This allows them to be mounted beneath often unavoidable ducts or piping. So here it is. Here's a picture of it. Again, this would be the whole 2x4 foot opening. And again, this needs to have ceiling wire suspended by at least two corners of this. LED luminaires, they're rapidly replacing incandescent luminaires and recessed lighting, many other applications. New legislation banning incandescent lamps from the market since 2023 will certainly accelerate the LED's use in both retrofit and new construction projects. So this is a fisheye. You can move this around and aim this light where you want it. You can shine it on artwork hanging on a wall, or you can shine it straight down if it's over like a sofa or something. Here's a commercial retrofit LED downlight. Suspended luminaires. Suspended luminaires are hung from ceiling using chain, aircraft wire, cord, or metal stems. Included in this group are chandeliers and pendant units. So, chandelier is a type of suspended luminaire. I'm going to put suspended luminaires. I know it's not going to make much sense, but I'm going to say suspended luminaires are chandeliers and pendant units, just because there's a question that says a chandelier is a type of, and the answer is suspended luminaire. So here's your suspended luminaire. That's a chandelier. It says use of ceiling luminaires. For large residential rooms, using more than one ceiling mounted luminaire improves efficiency and evenness of lighting throughout the space. A single luminaire may be too bright in the center, leaving the walls and corners dark, A widely used alternative is to also install perimeter recessed luminaires to light up the walls and corners of the room. So the chandelier in the middle of the room will be a centerpiece, being attractive, not giving out as much light as you need in that room, but certainly providing some level of ambient lighting. And then you can have recessed lights around the perimeter of the room, offering more light on the walls and more environmental lighting in the room. Track-mounted luminaires. Track-mounted lighting systems include the track, an electrical feed box, and one or more luminaires that can be positioned along the track. Track light wiring is inside the metal track channel. Single circuit or multiple circuit wiring can be used to allow one or two more sets of luminaires to be independently controlled. With all track lighting, the luminaires, the track, and the fittings must be listed for use together. So here's a track, and these lights can be moved along this track wherever you need them. They can be aimed. A lot of showrooms have this type of lighting because as you move stuff in the room, it's very easy to re-aim the lights at the counters to display whatever you're selling. If it's cell phones or pianos or whatever, you can change the position of those. 3.1.5 pole-mounted luminaires. These are usually outdoors. These are like parking lot lighting. Pole-mounted luminaires can be used for area, street, and sports field lighting, as well as for bollards and post tops. The wiring to the luminaire can be provided via an aerial drop to the top of the pole, a surface-mounted conduit on wooden poles, or internally with a handhole near the bottom. Although many types of light sources can be used with pole-mounted luminaires, the trend is toward LEDs. So here's a pole-mounted luminaire. Like I say, you see them in walkways and parking lots a lot. Choice of luminaire is usually done by a lighting specialist, and it's is dictated by considerations such as pole height, spacing, required illumination, light spill, color rendering, and more. As shown in Figure 27, the same poles are often used as a convenient mounting point for cameras, antennas, solar photovoltaic panels, and other related gear. 3.2.0 Storing and handling lamps and luminaires. Prior to installation, it's extremely important that lamps and luminaires be handled and stored properly, both while in transit and at the job site. Failure to do so can result in broken and/or damaged lamps and luminaires. The proper handling and storage of lamps and luminaires begins by using some common sense. Manufacturers of lamps and luminaires mark their shipping cartons, pallets, etc. with handling and storage instructions. First thing you should always do is read and follow all instructions. Obviously, lamps and luminaires are fragile, therefore pallets and/or cartons should not be dropped or otherwise handled roughly. If you're responsible for receiving a shipment of lighting products, make sure that there's no obvious damage to the shipping cartons. Many luminaires are fragile. Also make sure that the entire quantity that was ordered is delivered, or that the delivery ticket shows what's missing. Somewhere in here it's going to tell us to, oh, here it is. When handling a luminaire, wear clean gloves to prevent grease, dirt, etc. from getting on the decorative surface, and to protect your hands from cuts. Also make sure not to lose or misplace the mounting hardware and insulation supplied with the luminaire. So wear clean gloves to prevent grease, dirt, etc. from getting on the decorative surface, and to protect your hands from cuts. Some of these luminaires are very sharp, especially those troffers that we're talking about, the 2x4 lay-ins. They're stamped out of a piece of sheet metal and bent to shape, and the edge that is stamped is cut. It is sharp as a knife. It'll cut you big time. So be very careful when handling those. Most luminaires require a minimum amount of preparation before use. Some are shipped fully assembled, while others require minor assembly, which should always be done according to the manufacturer's instructions. 3.3.0 Installing luminaires. Before starting the actual installation of luminaires, it's extremely important to review the lighting floor plan and related luminaire schedules, or thoroughly familiarize yourself with the different types of luminaires to be installed and their locations. Given this information, you can distribute the different kinds of luminaires to the areas within the building where they are to be installed. So here's a ceiling, reflected ceiling print, electrical. It shows all the lights. So there's a type of light. It's a 2x4. It's probably a lay-in. It's a recessed, and it's 2x4 troffer, and it's an FA. And all of these rectangles represent FAs. So we could count, we need 5 in each room. So we could bring 5 on a pallet and just leave that pallet in the room, or we could move them by hand. There are 2 in each bathroom, the men's room and the women's room. And then there are, again, 5 in each classroom over here. Then there's an FB. It's 1 foot by 4 feet. It's a wraparound. It's a surface mounted, but it's 1 by 4 and it's fluorescent. So here are some FBs down the hallway, down this hallway. These are all the FBs. FCs are recessed. It's a downlight. So if we look, this is an FC. This one's on the emergency circuit because it's colored in, so it's going to come on when all the lights go out. And this is an FC, and this is an FC, and these two, these are all FC fixtures. All of these are type FC fixtures. They say it's a recessed downlight. So G by 24. Okay. Here's some over here as well. There's one. That's an emergency. It's on the emergency circuit. And then you have exit lights. Exit lights. And emergency lights. An emergency light will come on when the lights go out. So if they have these on an emergency circuit, there's a generator or a separate power supply for everything on that panel. And these emergency lights have their own battery included inside of them. So here's one, and there should be one in each restroom so that you can get out of the restrooms. I don't see them. Well, all right. There's an exhaust fan. Here are some FAs, 2x4. Again, I don't see any emergency lights inside the restroom. That's weird. There have to be. All right. Anyway, I don't see them, but there should be some in there somewhere. Maybe I'm just overlooking it. And then HC is a recessed 175 watt metal halide downlight. I don't recall seeing any HCs unless they're outdoors. There's an outdoor light. It's an FC. Oh, there's an HC. There you go. I think this is an HC, and I think this is an HC. I think that's a misprint. HC, that's the metal halide down lights. They're outdoors. HC. There's one at every entrance. And then we talked about the exit lights and the emergency lights. You should have exit lights at every exit. Here's an exit light. And here down this hallway, here's an exit light that shows you can go out here or you can go out this way. There's an exit light, exit light, exit light. It shows you how to get out of the building when the lights go out. All right. Appendix 26203-23A shows a summary of symbols commonly used on floor and building plans to identify different types of luminaires. That same appendix 23B provides troubleshooting procedures for various luminaires. Shop drawings should be studied prior to installation, and if there are any questions, the luminaire manufacturer or lighting designer should be consulted. So this is showing us that we can mount this to the box and bring the wires through the box and hook these wires up to it, and then push all of the splices back through the hole, and then we can bring this hinged cover down and put a screw in, and then that holds the light as well. So the screws that go into the box, the junction box, that holds the light. Typical information that can be found marked on luminaire labels and or given in the installation instructions are the type of lamps to use, an approval for use in suspended ceilings, the range of ambient temperature, the type of wire to use, the thermal protection, suitability for wall or ceiling mounting, suitability for use in damp or wet locations, suitability for use as a raceway, suitability for installation in concrete, mechanical installation instructions, electrical connection instructions, details for LED luminaires, or driver installation. Here's a highlight. It says NEC Article 410 sets forth most of the requirements pertaining to the installation of luminaires. So Article 410 is for luminaires. Okay, I'm going to keep going. So it says here the specific method and hardware used for mounting and supporting luminaires depends on several factors, including type of luminaire, the location of the luminaire, the construction of the mounting surface, the weight of the luminaire, and the manufacturer's installation instructions. Surface mounted luminaires. Surface mounted luminaires include those that are directly mounted on the ceiling or wall. Again, there's a box behind it. I don't want you to think that we're just bringing Romex through the ceiling and hooking it up. A luminaire should be mounted to its outlet box using the mounting hardware supplied with the luminaire and installed according to the manufacturer's instructions. If you're not thoroughly familiar with the luminaire to be installed, first read and be sure that you understand the manufacturer's product literature and installation instructions. All right, so here's a hanger bar, and on it we have a box supported so that it sticks down through the drywall and is just flush with the surface of the drywall once they put the drywall up. And you bring your wiring or piping or flex into it, and then you can make up your splices inside that junction box. So this one's a hanger mounted, this one's screwed to the side of a rafter, this one is a pancake box underneath the rafter. These are usually only a ½ inch deep so that they will be flush with the drywall. And here's an octagon box. Notice there are only knockouts in 4 of the openings of the octagon. These other sides are usually just slightly rounded. We can't get a lock nut on a rounded surface, so you don't put any piping extensions in these 4 corners, only in the flats that have the knockouts factory installed. For concealed wiring and wooden frame construction, the outlet boxes are fastened directly to stud joists or other framing members using nails or screws. Some ceiling outlet boxes are mounted on an adjustable hanger bar so that the box can be installed in the space between the ceiling joists. The box is attached to the bar hanger by a luminaire stud or 2 bolts. All right. Let's see here. The size and weight of the luminaire determines what type of outlet box should be used with the luminaire. When mounting luminaires that weigh more than 50 pounds, NEC section 314.2782 requires that the luminaire be supported independently of the box, unless the outlet box can handle the weight. Boxes used at luminaire outlets in a wall must be designed for the purpose and marked to indicate the maximum weight of the luminaire to be supported. If other than 50 pounds, in addition to complying strictly with code, good judgment must also be exercised. Remember, codes only give the minimum requirements for the electrical installation. It's always a good idea if you have a luminaire that's even approaching 50 pounds. Go ahead and support it independently of the box. If that means taking this hanger bar out and putting a 2x4 across here, and then putting a saddle box, that's fine, do that. That way you can put lag screws up into the 2x4, holding a bracket that holds that fixture. You can drop all thread down. If you have framing members that will accept an all thread hanger, you could hang all thread right down through the center of the box. You could use that to support that heavy fixture. You don't want to support it from the box with 632 or 832 screws. That's not enough. Caution: when a manufacturer supplies insulation with a surface-mounted luminaire, do not throw it away. It must be placed between the luminaire and the mounting surface to insulate the mounting surface and wiring in the fixture box from the heat produced by the luminaire. Make sure to install any such insulation as directed by the manufacturer and replace it with equal material if it is damaged or discarded. Some of the installation considerations for various types of surface-mounted luminaires include the following: drum, globe, or sconce, and similar luminaires. Figure 31 shows some common methods used to mount drum, globe, sconce, and similar types of indoor luminaires to an outlet box. Sconce is usually wall-mounted, just so you know. I thought that they were going to show us pictures of a sconce, but all right. It's a wall mounted. They'll call it a sconce light. Like if you have a fireplace and you have a light on either side of that fireplace, those are called sconces. All right. As shown in Figure 31A, the common porcelain type lamp holder luminaire screws directly to the ears of the outlet box. Other ceiling luminaires and wall sconces are fastened to the outlet box using a mounting bar that's attached to a threaded stud in the box as shown in Figure 31. So all of these they're talking about are probably less than 15 pounds. This one is mounting directly to the box with the 832 screws. This one has a mounting bracket, and that bracket is held to the box with the 832 screws, and then the studs hanging down will mount the fixture itself. But again, it's being supported by the actual box itself. I guess this is a continuation of this one right here, showing you that you can use this fixture stud and a lock nut to support that. This one's using the box screws and the fixture stud. All right. Fluorescent and LED luminaires. Some lightweight surface-mounted luminaires can be supported directly from an outlet box. Such types typically use a stud reducing nut and nipple in the box with a mounting bar inside the housing as shown in Figure 32. So this lightweight fixture can be supported directly from the box. They're using a fixture stud and a nipple, and then they're going to put this mounting bracket. This mounting bracket would actually be above this fixture, and it would be held to the box with a lock nut. And then you'd put two screws up through the fixture and screw them into this mounting bar. Actually, it looks to me like they're trying to say this mounting bar is going to go across this opening, and there are no screws holding it. I don't know if I've ever seen one like that, to be honest with you. All the ones I've ever seen have threaded holes, and you put it across the box, and then you go up through the fixture, and you screw into those threaded holes to support it. Chandeliers and pendants. Typical methods for attaching chandeliers to an outlet box are shown in Figure 33. Chandeliers are normally heavy, requiring that they be mounted on a box with a stud. A hickey or a hickey, a hickey or a hickey together with a threaded adapter is installed over the luminaire chain and wires and then screwed onto the stud. The luminaire base is then fastened to the hickey or adapter with a lock nut or cap nut. So here's a chandelier, and the wiring goes up the chain and goes inside of this base plate, and then it goes up through this fixture hickey, and then you can wire it up in the box. And the fixture hickey is attached to this fixture stud that holds the weight of the chandelier. Again, the chandelier can't weigh more than, I think it's a maximum of 50 pounds, or it needs to be independently supported. Ceiling fans. NEC section 422.18 covers the support of ceiling hung fans, paddle fans. It refers to NEC section 314.27 C and E. NEC section 314.27 C states that for fans weighing 70 pounds or less, the outlet box may be used as the only support for the fan if the box is listed and marked for such use. If it's more than 30, if the box is made to support more than 35 pounds, it'll be stamped on the metal of the box. The code also requires that boxes designed to support fans weighing over 35 pounds must be listed for such use and marked with their maximum weight to be supported. Extra support can be provided by mounting the box on a fan joist hanger. NEC section 314.27E permits the use of a listed locking support and mounting receptacle in combination with a compatible factory installed attachment fitting designed for the support of luminaire or fan within the weight and mounting orientation limits of the listing. So here they're showing a bracket bar, and it's between two studs, and then you can support typical fan joist hanger. This one has a hanger bar across the box, and then the canopy is fastened to that hanger bar with these screws. Outdoor luminaires. The methods for attaching outdoor surface-mounted luminaires or outlet boxes are basically the same as those described for indoor surface-mounted luminaires. However, the installation must be done so that the final assembly is watertight. All luminaires installed in wet locations must be marked as suitable for wet locations. All luminaires installed in damp locations must be marked as either suitable for wet locations or suitable for damp locations. All right. When mounting a luminaire to an outlet box that's fully exposed to the weather, the outlet box must be a metal weatherproof box, while washers, gaskets, etc. that are required to make a watertight assembly must be properly installed as directed by the manufacturer. So they give you this rubber washer that goes down in the socket, and then the lamp is screwed in to the socket with this rubber gasket around the base of it. So here are a couple floodlights being mounted overhead, and again, there's a rubber gasket or washer that's going to go inside of here, and the lamp will screw down to it. Recessed luminaires. It says warning, recessed luminaires generate a considerable amount of heat within their enclosure and are a fire hazard if not installed properly. For this reason, the code requirements given in NEC Article 410, as well as in the article referenced in Figure 36, must be strictly observed when installing these luminaires. And it'll tell you IC, listed pre-wired fixture with junction box. It'll tell you that it's in insulation contact or non-insulation contact, and you have to keep the insulation 3 inches away from it all the way around. The minimum length of this fixture whip is 18 inches, and the junction box has to be a minimum of 1 foot, 12 inches away. So junction box must be at least a foot from the fixture. Branch circuit conductors with insulation suitable for the temperature requirements marked on the listed pre-wired recessed fixture may be run directly to the junction box on the fixture. It says fixture whip is not required to be supported if it's 4 feet or shorter. And it says it may be 3/8 inch flex. They say a minimum of 1/2 inch flex, and there's an exception saying that for a fixture whip we can use 3/8 inch flex. Fixture whips must be at least 18 inches long, but not more than 6 feet of suitable raceway, with conductors having insulation suitable for the temperature encountered. Okay. And there you go. Here's the non-insulation contact, non-IC. You have to have 3 inches. Keep thermal insulation at least 3 inches from fixtures unless they're identified for direct contact with insulation. Here's an IC fixture. Here's a non-IC fixture. Very difficult to keep this insulation 3 inches away. As soon as you leave and someone slams a door, this is going to just fall in on it. So recommend to your customers that they get insulation contact recessed fixtures. Wiring for luminaires. Here's a highlight. It says in a suspended ceiling. The length of the luminaire whip must range from a minimum of 18 inches to a maximum of 6 feet. Whips can be made from any of the following: trade size 3/8 inch, or metric designator 12, flexible metal conduit using conductors suitable for the temperature requirements stated on the luminaire. Armored cable, or trade size 3/8 inch flexible non-metallic conduit with conductors and grounding conductor suitable for at least 194 degrees Fahrenheit or 90 degrees Celsius. All right. Always refer to the manufacturer's instructions when installing any luminaires. A general installation procedure includes the following steps. Extend the luminaire mounting bars to reach the framing members. Position the luminaire on the mounting bars to locate it properly. Align the bottom edges of the mounting bars with the bottom face of the framing members. Then nail, screw, or otherwise attach the bars to the framing members. Remove the junction box cover and open one knockout for each cable entering the box. If required, install a cable clamp for each open knockout and tighten the lock nut. Run the branch circuit wiring through the cable clamp and into the luminaire connection box. Make up the electrical connections, and after the finished sealing is in place, install the lens, diffuser, and or trim on the luminaire. Luminaire trim combinations are marked on the label inside the luminaire. Installation considerations for various types of recessed luminaires include the following: incandescent, compact fluorescent, and high-intensity discharge recessed luminaires. These luminaires are all mounted in the ceiling in basically the same way. The rough end of these types of luminaires must be completed before the ceiling material is installed. As shown in Figure 37, they typically include captive adjustable bar hangers for attachment to wooden joists or T-bar grid ceiling members. Recessed luminaires suitable for through wiring are equipped with feed-through junction boxes, which allows a series of fixtures to be wired together or a branch circuit to be fed through the housing junction box. So here's the junction box on the side of the recessed fixture. They're saying that these bars have to be expanded to reach either the T-bar grid or to be nailed on the inside or screwed on the inside of the wooden joists. And this is done before the drywall is put up. And there's your junction box on the side where you make all of your splices. Fluorescent and LED troughers. The code requirements for the installation of recessed fluorescent and LED troughers are basically the same as those for other types of recessed luminaires. Recessed fluorescent and LED troughers are inserted into the trough-in opening in the drywall, plaster, or other ceiling types and fastened in place using various devices. So, if a suspended ceiling supports recessed fluorescent troughers or other luminaires, Section 41036B requires that all ceiling framing members be securely fastened together and to the building structure. This job is normally done by the installer of the ceiling grid. The proper support of suspended luminaires is a critical safety issue for both occupants and emergency personnel who may be called into the building in the event of an earthquake or fire, etc. So they want to make sure that these fixtures don't fall out of the ceiling. They have to be suspended. And I believe that it's code that you have to suspend the fixture itself from two opposite corners or the ceiling grid right next to the fixture. And then the fixture has to be secured to the grid using either, here in Florida, we call these hurricane clips. In California, they're called earthquake clips. Same thing. All right. 3.3.3, suspended luminaires. Here's a highlight. Suspended luminaires used in commercial and industrial buildings can be supported in numerous ways by the building's structural members. So here are different ways that they support suspended luminaires. They have a T-bar clip, adjustable swing hanger, I-beam clip, so it goes on the side of an I-beam, and you can use all thread to hold the luminaire. Here's a beam clamp that goes on, and then you can, again, thread it. Here's a flange hanger that goes on the side of either the T-ceiling support, or it can be slid onto a purling or an I-beam, and then it supports this rod. And it's for lighter weight fixtures. This one has a threaded flange that you can put two lock nuts on it, keep it from going anywhere. All different types of hangers. Generally on large construction jobs, specific method for hanging suspended luminaires is shown in the construction drawings. However, for many smaller jobs, the method used for suspending luminaires is frequently left up to the electrician to determine. This can be a problem for less experienced electricians. Fortunately, technical help is readily available. To aid customers, manufacturers of fasteners and metal framing devices produce numerous catalogs and technical support bulletins that show examples of solutions to common suspension problems. So here they're showing you that you can suspend a fixture from a T-rod. You can use these kind of caddy clip anchors. Here are some that are suspended on the side of purling. You can use chain. Here's the clips on the side of the purling holding the bar that the fixtures are mounted to. A lot of times they use all thread. All thread's a very good way of supporting things. So you can go up between the rails of the purling, put some fender washers, nut on top and bottom, tighten it down, and then that all thread's not going anywhere. You can use that to support the fixture. So here it says, clip the fixture to the grid where shown and plug into the nearest receptacle. And a lot of times you don't have receptacles in drop ceilings, so you can either add one or you can hardwire it to a junction box. Cord with plug mount, cord with strain relief on the top of a J box. Here's the fixture canopy with transformer, and these are brake lines saying this can be as long as you want it to be. Here's a heavier light. This is more for either photography or video or stage production. And again, they're going to suspend it from, here's all thread coming down from the roof decking. And they'll suspend this clip, and then they'll suspend the light off of one side of it. Okay. Track luminaires. Track mounting lighting systems include track rail, an electric feed box, 2 or more luminaires that can be positioned along the track, and various types of accessories and other components that allow assembly in any pattern. So here's a connector. You can connect 2 rails together. Here's a T, an X that you can go in 4 different directions. Here's an L corner. Here's a T. So you take the straight lengths of track and they plug into these, and these connectors on the side feed the rails hot, and they will be fed from a box. There will be a box. Here's the floating power feed for the entry anywhere along the track. Basically, there's a junction box up in the ceiling, and then this cover goes over the junction box, and then you wire the whip to the rail. There's a straight connector. There's a canopy kit outlet box cover. So it goes over the box, and then the rail system is fed through it. Okay. It says track lighting wiring is in the metal track rails. Single or multiple circuits in the track allow 2 or more sets of lights to be independently controlled. The track is an extruded aluminum channel that holds 2 or more electrical conductors in separate insulated grooves within the channel. The inside surface of the conductors are bare. When a track luminaire is snapped into the track, 2 terminals on the luminaire contact the track conductors, supplying power to the luminaire. A lot of times they'll have like the hot and the neutral on one side and the ground on the other, so you can only turn the stem of that track light one way. It has to go in and turn 90 degrees, and it has to make contact with all 3 of those. It won't turn the other way. So you put it in, you snap it in, and then the light can be positioned anywhere you need it. Track lighting systems are made so that the proper electrical polarity is always maintained. The polarity lines inside the track must be aligned with the sections of track installed. The luminaires will snap into the track in only one way. The NEC requires that luminaires, accessories, etc., that are used in track systems be specifically designed for the track on which they are to be installed. Can't mix and match. Here's a highlight. It says, when installed on a wall, the track must be at least 5 feet above the finished floor, except where protected from physical damage or when using low voltage, less than 30 volts, track. I've never understood that. I don't know why 5 feet is the cutoff, because people can reach up 5 feet. But it says they have to be at least 5 feet above the finished floor to be mounted on a wall. So the NEC requires that the track be fastened so that each fastener is suitable for supporting the maximum weight of the luminaire that can be installed. Unless identified for use with supports at greater intervals, a single section of track that is 4 feet or less in length must be supported at least 2 places. If more track is being used, at least 1 additional support for each individual extension that is 4 feet long or less must be used. So, when using a wire-in connector, track clips that are spaced apart at the required distance are used to hold the track 1/4 inch to 1/2 inch away from the ceiling or the wall mounting surface. The clips are fastened in place using screws, toggle bolts, or other appropriate fasteners. It's a good idea to snap a chalk line from the center of the outlet box or the center slot on the track connector to the proposed end of the track. Once clips are installed, the first section of track is fitted solidly into the track connector, and then the track is snapped into the clips. Following this, set screws in the sides of the clips are tightened to hold the track firmly in place. Remaining sections of track are installed in the same manner using the appropriate connectors and accessories. So either using a straight connector or an L connector or a T or an X. Another type of track lighting is covered in Article 393, low voltage suspended ceiling power distribution systems. These operate at a Class 2 circuit limited to 30 volts or 60 volts AC to supply power to luminaire control and signaling systems that operate within these limits. Making electrical connections to luminaires. Making the electrical connections between the luminaires and the box. Wiring is done at an appropriate point during the installation. The specific way in which the wires in the outlet box are connected to the luminaire wires varies depending on the design of the branch circuit and the way in which the branch circuit cable or raceway wiring is routed. Most common type of electrical connection is a conventional hardwired installation. The connection of the luminaire wiring to the outlet box as supply wires should be done in accordance with the manufacturer's instructions. The general procedure is basically the same no matter what type of luminaire is connected. Here's a highlight. It says NEC section 300.14 requires that at least 6 inches of free conductor length be left at each outlet or junction box where it emerges from its cable sheath or raceway. So you need to use a minimum or leave a minimum of 6 inches of free conductor in that junction box. All right. Well, they go on to say for splices or connections of luminaires or devices, each conductor must extend at least 3 inches outside any box opening. That's less than 8 inches in any dimension. The 3-inch length is generally measured from the outer edge of the box. So, minimum of 6 inches of free conductor and a minimum of 3 inches extending out of the box. The luminaire's black wires are connected to the outlet box hot wire, the black, red, or marked hot. The white wires are connected to the white wires. If dealing with non-metallic cable and metal boxes, the bare ground wires should be spliced with one end of the ground jumper. The other end of the ground jumper should be attached to the box using either a ground clamp, clip, or the box ground screw. If dealing with non-metallic cable and non-metallic outlet boxes, the bare ground wire should be spliced together. In some cases, a green wire from the luminaire and the bare wires will be connected to a grounding screw provided on the mounting bar supplied with luminaire. So that fixture has to be grounded even if the box is plastic and you're using non-metallic sheath cable. You still have to ground the fixture. So a wire splicer should be made using the correct wire nut sizes for the number and gauge of the wire used. If in doubt, wire nut manufacturers mark their packages to show the minimum and maximum number of wires that can be connected with the product. The NEC requires that all luminaires with exposed metal parts be grounded. If the luminaire has a separate green grounding wire, it should be spliced together with the other grounding wires. Once the luminaire box or metal mounting strap is grounded, the nipple or screw holding the luminaire will ground the luminaire. All right. Guidelines for making other types of wiring connections include the following. Modular system wiring. Some installations, luminaires are connected using a modular wire system. Modular wiring provides an alternative method to conventional hard wiring for power to open office partitions and luminaires in grid-type suspended ceilings. Modular system components are interchangeable and can be reused. Component labels are color-coded to identify the rated voltage. Ooh, that's a highlight. Component labels are color-coded to identify rated voltage, and the units are key to prevent mismatch. All right. So here is a modular system where they send you whips of varying lengths and a blueprint, and it's just plug and play. Here's the outlet or junction box going to the first feeder adapter, and then after that, everything just snaps together. Okay. Strut channel wiring. Non-perforated strut and similar structural members are frequently used to both support and provide a wiring raceway for powering luminaires in commercial and industrial lighting systems. So here they're bringing these conductors alongside this strut, and then they're feeding it out where the fixture is suspended by a steel cable. And then this goes through a nipple and feeds the fixture. Lighting trolley busways. Lighting trolley busways use a special channel similar to strut with insulated conductors installed similar to track lighting. Stationary plug-in devices, commonly called twist outs, are made to attach the luminaires at fixed points. Wheeled trolleys allow attached luminaires to be moved at will. Lighting trolleys, busways are used in industrial and some commercial lighting applications because they allow the lighting system to be reconfigured as needed. So here is a lighting trolley busway, and they call these lights, this is a trolley, and it can be put in at any place along this track. Here's the messenger cable supporting this trolley, or this busway. Okay. Section 3 review. Fluorescent or LED troffers are typically a type of, it's a recessed luminaire. Which of the following is the best tool for opening a luminaire carton? They're going to say a utility knife. Unless otherwise marked, boxes for indoor ceiling mounted luminaires can support a luminaire weighing no more than 35 pounds if they're not marked. If they're up to 50 pounds if they're marked with their maximum weight. All right, very good. Well, this concludes 26203 electrical lighting. And as always, I hope you got something out of it. If so, give me a thumbs up and consider subscribing to my channel. And as always, I'll see you on the next video. Thank you.